Okay, now we're going to look at complex conjugates. So for a complex number of the form a plus bi, its complex conjugate is a minus bi. So everything's the same, you just change the sign of b, or the imaginary part. Okay, so here's an example in 3. So if you start off with 5 minus 4i, then the complex conjugate is going to be 5 plus 4i. And I should say that a lot of times we use the notation that if you have a number a plus bi, then its complex conjugate, you just write a line over top of the whole thing. And that means that's to remind you to change the sign. So I should say that, like, if you take 5 minus 4i and you take the complex conjugate of that, that becomes 5 plus 4i, is one way of writing this. Okay, so now let's take the complex conjugate of 3i plus 7. So that's going to become 7 minus 3i, because remember, you're changing the sign of b and not the sign of a. And in this case, a is 7, b is 3 there. So that the complex conjugate is 7 minus 3i. Alright, and try to do part C and D on your own, and then check back in with this video. So in this case, this is negative 2i. That's like a plus bi, where a equals 0 and b equals negative 2. So if you look at it that way, the complex conjugate of negative 2i is just positive 2i. And then finally for D, that's a is 10 and b is 0. So the complex conjugate of a real number is just 10. So you don't change any signs at all because there's no imaginary part. Okay. And you might be wondering, why are complex conjugates useful? Well, if you multiply a pair of complex conjugates and see what happens, you'll see something kind of interesting. So let's just do an example. If I start off with a number like 5 minus 4i, and I multiply by its complex conjugate, 5 plus 4i, you should end up getting a real number. So let's try this. If you FOIL this, you get 25 for 5 times 5, and then outside is 5 times 4i, and then inside is 5 times negative 4i, and then finally you get minus 4i times 4i. So that's 25, and in the middle you have 5 times 4i and 5 times negative 4i, so when you add those together they cancel, and then finally you get minus 16i squared, but remember I squared is negative 1. So that's 25 plus 16. So you end up getting 41. So the cool thing is that when you multiply complex conjugates, even though they're complex numbers, when you multiply them, you can always end up with a real number.